Hello and welcome to part B of section 5 in the SAS programming course. In this section, we continue with data management tools and we start with selection of observations. So we also use an if statement here as we did in the last part, but we use it in a little bit different way. So if you look at this data step here, you can see that we have an if statement without then part as we did last time. So what this one is doing is that it takes this data set in the set statement as input. So data set called economic, and it has the condition if farm type equals anim. So it picks only the rows that fulfill this condition, and only those rows will be written to the new output dataset called new. Also, the if statement can be used to remove observation. In this example, we chose the ones that met the condition, but alternatively, we can define a condition like we have done here. We have chosen those rows that meet this condition, that farm type equals crop or farm type equals others, and then we say then delete, so those rows will be deleted. So actually these two data steps, they create exactly the same end result. This one deletes those two farm types, and this one keeps only that farm type, and when we have only these three options, they result into the same end result. Then there is a little question: why would this if statement not work if we compare these two if statements? You might notice that there is a little difference here. So this other group is written in slightly different way in these two if statements. This one has the capital O, and this one has the lowercase o. And in the data set, the farm type other is written in this way. And like we told earlier in earlier section that when we refer to character values in SAS, that's the only place where the case matters. So this one would not recognize the other values, and that would then end up doing what it's supposed to do. So in this case, when we are referring to character values, then you have to remember that the case matters. Then let's continue. Uh, we can also do grouping of observations using if statements. In this example, we have several if statements. In the first one, we say that if year is less than 1991, then we say that variable class gets a value 1. If year is exactly 1991, then class equals 2. If year is larger than 1991, so 92 upwards, and less than 97, so it will be in practice from 92 to 96, then class equals 3. And if year is larger than 1996, then class equals 4. So if statements can also be used to do this kind of grouping of observations, and you can create a categorical variable out of continuous variable using this technique. Uh, Then if you want to select or delete variables from your dataset, there's two statements that are quite usable in this case. You can use keep statement or drop statement. So simply in the keep statement, you list the variables you want to keep in the output dataset. Here we have listed year, status, and income. And alternatively, you can use drop statement and you can list the variables that you want to drop from the output dataset. Usually it's just a matter of which one is easier and shorter to write. Is it easier to write those you want to keep or those you want to drop? And in this case, keep statement would be the more simple one. Then next we go to transposing of data. So to put more simply, we either stack columns from several columns into one column, or we split a variable from one column to several columns. And typical situation where this is needed is repeated measurements data. You might have, for example, data from different years from the same farms, let's say, as an example. And often, for practical reasons, it's easier to enter the data so that each year, data from each year is entered into separate variables. But then, in some statistical analysis, you might be required to have all the response variable values in one column, and you would need another variable to indicate which year or each value is coming from. And sometimes you actually have to go the other way. You might have to split the values from one column to several separate columns. And next we check how we can do this quite easily. First, we look into the situation where we go from multiple columns to one column. Here is simple example data. We have a farm ID, and from this, for example, from this farm 101, we have income from year 23, income from year 24, income from year 25, all in one row. But what we would like to have three rows for this farm. First row would have the farm ID and the income from year 2023. And we would like to have a third variable that would be, for example, called year, and it would have the year 2023 as the value. And same logic, of course, for the next farm and so on. One way to do this is to use data step in this way. So basically, these three rows here are where the action happens. So in the first one, we say that year equals 2023, and so there we actually give the value to the variable year, and we say that income equals income 23. So that comes from the data, the value for the income variable, and then we output. And that makes it so that when these two things have been done, we already output the first row to the resulting SAS dataset. And in a similar way, we define what we are picking from these income 24, income 25, and then we also drop the original variables income 23 through income 25, and here is what we get as an end result. So this is actually doing what we were aiming. So we get three observations for each farm, or three rows. And so just a brief side note that we use the drop statement, eh, but we could have just as well used the keep statement to choose the variables we want to have in the out. Actually, I have a little mistake here in my slide. This says status, but it should state farm ID actually here. So keep farm ID year income would be what we would need. There is an alternative solution to do this transposing, and that's to use the proc transpose procedure, which is a tool specifically for doing this kind of transposing. And the way that works is that we define that we start with the data 3, that's the input data, and in this out equals option we can define that the output data will be saved as new 4 data set. We define that we want the values from variables income 23 through income 25, those put into one column, and we do this by farm ID. So the by statement is needed to identify the units here. So basically it's the rows in the original data that we start from. Then if we go to the other situation, the transposing from one column to several columns, so basically going the other way around, starting from the output of the previous example and going to the original version. That can also be done using the transpose procedure. And we first of all, the main rule in SAS is that if we have a by statement in some procedure, we first have to sort the data by the same variable, based on the same variable. So that's why we have the proc sort here. This takes the data set called new3 and it puts the rows in order based on the farm ID. This might already be true, but it's often good to have just in case if the data is not in order, and you get an error message if it's not true. Then in the proc transpose, we say that we again start with new 3, output is entered as new 4, and we'll come back in a minute what this prefix means. So again, we are defining that we want to do this by farm ID. So basically, in this case, we are saying that we want to have separate row for each farm ID. And then, oops, sorry. Then we are saying that the ID is year. So year is the variable that has 3 values, 23, 24, and 25. And for those 3 values, we want to have a separate column in the output data for each of those. So we get 3 columns, and the values will be picked from the variable income. And actually, this prefix is the first part of the name we give to those three uh, variables. So we start with year and then we get the 2023 as the next part and so on. So we get year 2023 and so on. And that's the output data set. That's how that's exactly what we were aiming for. Thank you.